Hello students, welcome back. Let's go back to section 2 and then do some more computations about tangency. And please note that I corrected the sign here now. X squared minus xy minus y cubed equals to 1. Sorry, I had a typo before. Okay, alright. Let's resume. We completed up to C. Let's go to D. Okay, we have to take the derivative of this. The left-hand side, something complicated, but don't be intimidated. We have some parentheses and squared, so it's a composite function. So all we have to do is to apply the chain rule. Does it make sense? And then the right-hand side is product rule. Left-hand side is chain rule because this thing, complicated thing, to the second power. So outer function first. 2 comes out and subtract 1 from the power. Inside never changes. Yeah. No change in the inside. And then we have to multiply the derivative of the inside. That's going to complete the chain rule. So shall we put in the derivative here? Okay, alright. 2x and the derivative 2y and then plus 2. Is that the derivative? No. 2x is okay, we took the derivative. Y squared becomes 2y times y prime. The derivative is 2 times y prime. Y prime pops up whenever you take the derivative with respect to y. Remember that. And the reason is the chain rule. Okay, by the side, let's use a product rule. The derivative of first function is 8x. No, excuse me, 8x is the first function. The derivative is 8. Second function is y. And first function, 8x, and the derivative is y prime. Please check. Chain rule, product rule. Okay, alright. Let's plug in numbers. X is 0. Okay, so that's 0. And then x is 0. And then x is 0. And then y is 2. Times 2. And then times 2. And then you can keep it as y prime. I mostly do it that way, but I found that students do a little bit better if you plug in m first. So I just did. I usually keep y prime. Okay, alright, and let's do this computation. Let's see, what do you have here? 0 minus 2 squared is 4. Plus 4, so this entire thing is 0. Is that right? 2 times 0 times whatever. Right hand side is 16 plus 0. Did I do this right? 8 times 0 times m is 0. 8 times 2 is 16. 2 times 0 minus 4 plus 4, so that's 0. Times here, I could do the computation. 0 minus 4m plus 2m, so minus 2m. But it doesn't matter, we are multiplying by 0. So I'm getting this conclusion. 0 equals to 16. If something like this happens, please check your computation first, because this is certainly not true. Now, if everything is right, then you come to only one conclusion. The derivative does not exist. If m exists, then it would have worked, but it clearly does not work. So derivative does not exist. Slope does not exist. What kind of line has no slope? A vertical line. X0 is 0 in this case. So that's the slope of that's the equation of the tangent line. Slope is undefined. Undefined slope, that means it's a vertical line. And whatever x0 value, you're going to get that. In this case, x equal to 0. Let's see. Okay. Chain rule, plug in the value, we get 0 equal to 16, same answer as before. Therefore, m is undefined. It must be a vertical line. So whatever x0 value, of course, if you plot it, you'll see we have a curve like this, and then 0, 2 is here, and we have to have vertical line. Here, in this plot, I didn't plot the coordinate axis because coordinate axis will override this. So you cannot see this vertical line clearly, so I drew it without coordinate axis. Instead, I drew a frame, -3 to +3, -2 to +4. So coordinate axis will go, x-axis will go like this and that, and this actually is the y-axis, x equal to 0. So vertical lines do happen for implicit curves. Rare, but it does. Let's see, what other examples do we have? This one here is similar to the previous problem in a sense that we have to use a chain rule and something. Okay, alright, stop the playback and try E. Got it? Okay, let me show you. Implicit differentiation goes like this. Left-hand side is pretty simple. X squared becoming 2x, 8y squared, 16y, but y prime popped out. So y prime popping out, very, very, very important. Right-hand side is chain rule. 2 comes out, subtract 1 from the power. So there's nothing there, 1 is hidden. And then nothing changes inside. We have to multiply the derivative of the inside. Most of the time I just use bracket for that, but hey, that's fine. And then y prime popping out whenever we have to take the derivative by y. Alright, we have to plug in numbers. Go ahead and plug in numbers. X is 1, y is 1, and y prime is m. Do your computation, what do you get? 2 plus 16m, and then 2, and then 4, 3, 6 times, so right. 1 plus 4m, and then break up the parentheses. I'm getting m equals -1/2. Okay, slope and the point. We have the answer. Okay, running through this right here. Okay, how about this? We have an exponential function to the left, and then right-hand side looks very easy. Stop the playback and try. What do you have in the left-hand side? Exponential, so what you take the derivative? Chain rule says exponential function, that's the outside, and exponential stay the same. And chain rule says inside never changes, alright? And then we have to multiply the derivative of the inside. What's the derivative of x over y minus 1? Minus 1, no big deal there. That derivative will be just becoming 0. X over y, oh, looks like that's going to be a quotient rule. So we have x over y, and that this is going to be y squared. And then in the numerator, we have, well, the structure of the quotient rule. Shall we go ahead and do that? The derivative of numerator is 1, denominator, minus numerator times derivative of denominator, y prime. So that goes to the numerator. Come on. Okay, highlighted in red. And then right hand side, oh, that's easy. Calculate the derivative. 2x becomes 2 and 2y, but y prime. Don't forget y prime. Forgetting y prime is a major mistake because the whole process just find out y prime, evaluate it at some point. Okay, here, if you plug in x equals 1, y equals 1 and do your computation, you're going to get something. Here, if you plug in x equals 1 over y equals 1, so 1 over 1 minus 1, so this thing will be e to the 0 power. E to the 0 power is 1, so this computation becomes pretty simple. Here's the solution. Derivative computation, as I did before. Exponentials stay the same. By chain rule, you have to take the derivative of the inside, and that requires a quotient rule. And then plug in the numbers. And then here, I didn't bother plugging in m as y prime. That's okay too. And then so for y prime, that's 1, so slope is 1. Point is 1 comma 1, so point slope equation will give you that. And yep, y equals to 1. I mean, y equals to 1x. Final problem? I don't have enough time, I guess, but let's try. Stop the playback and try first. What do you get? Well, sine becomes cosine, cosine becomes negative sine, but y prime pops up, you know, remember. And the right hand side, we're going to have to use the product rule, I guess. Okay, here we go. Sine becomes cosine, cosine becomes negative sine, but y prime pops up by chain rule. And then product rule. Sine becomes cosine and the second function. And first function stay the same. Cosine becomes negative sine, but y prime. So that's first line is the derivative computation. And here I decided to do some simplification before plugging in numbers. Okay, some negative sign there. Okay, all right. And then plug in pi over 4. Sine of pi over 4, 1 over square root of 2. Cosine of pi over 2, that 2 is 1 over square root of 2. So plug those in and you get this equation. And then bunch of square root of 2, so you can do a lot of simplification there. If you do all the problems, all the computation right, square root of 2, square root of denominator, square root of 2 numerator, denominator, cancel out. And then we have square root of 2 in all the same denominator. So remove them all, and you're going to get something simple. You get y prime equals to 1. That's a slope. That's a slope point equation. M is 1, and the x minus x naught plus y naught. So, implicit differentiation, and then plug in a number, simplify. So for the slope, here's a visualization. Well, okay, we went through a lot of tangency problems here. Okay, that completes section 2.